Hello, everybody. Here we are back in another episode of Analytics Mindset. In this specific episode, I will go over Python data types and some of the implications on some of the most common data manipulation techniques in Python. First of all, I'm using Spyder version 5.3.3, and you should at least see my absolute basics for Python video. I do have some other videos that build up into that video, including this one. So if you want to have at least the most basic knowledge and background, and you're not familiar with Python, please look that video beforehand. It will also be somewhere over here. With that being said, we will start by importing our required libraries that are NumPy and Pandas, and you will see soon why we are doing this. After this, data types are tricky. You can think them as how Python is treating a variable in some cases. It goes way more complex than that, but for the purposes of this video, I will keep it very short and very concise. Just think about the way that the Python programming language is seeing your data and what it can do with it. And it will make more sense once we go through some examples. Some basic data types are Boolean, integer, and string, and I will go through each of them right now. I will run this one, and if you don't remember, I am just assigning the value of true, that is a Boolean, to a variable called Boolean var. And as you can see, it's also stored here in our variable explorer that for most of the video, we will say we don't have this, even though you can check here, it says name, type, bool, size 1, and the value true. We will do the same with the integer and with the string. So we have three variables, one Boolean, one integer, and one string. This has a value of true, the integer one has value of 4, and the string variable has the value this is a string. That is pretty self-explanatory, easy as a text. Now we're going to use this. I will not go in details about the print function. You can read the documentation if you want to be more familiar with it. But F basically allows us to put a placeholder that then calls some code inside the print function. So when I do this, you can see that the type of these variables are class bool, that is the result of this type Boolean variable, class integer, the result of this one in the curly brackets, and class string, the string variable. Again, it's just a formatting to have these three pieces of code printed nicely. There is a lot of ways you could have done this differently. Again, I'm not going to elaborate because we are focusing on data types, but it is just a nice way to print stuff when you need to execute some code or even call a variable. Now you can see each of these three variables has a different data type. And we can also see that some functions will do different stuff depending on what your data type is. So if we try to run length on the Boolean variable, we get an error because the object of type bool, as you can see here, object Boolean, it doesn't have any length, at least for Python. We can do the same with the integer one. We see that the object of type integer has no length as well. What if we do it with the string one? You will notice we have 16. That is here the value that we have, 16. And if you want to be very picky, you can actually count. This is a string and it will have 16 characters in total. So some functions will work when you have a certain data type, some of them will not. In general, you just want to be aware of what data type you want to use and how you want it to read your data. And that is even more important when you're importing data from somewhere else, because even though you may assume that it must mean a certain data type, Python may read it differently. It's more so if you're doing something like read CSV, for example. And to give a very big perspective on this, let's say that we have the value 4, but we have it as a string instead of an integer. We are taking 4 here. And now if we print this, just for demonstration purposes, you can see how it's 4. The value is correct, but notice that it's not your regular 4. If we call the integer variable, just for a comparison purposes, you can see that it's a 4 but it's a number, it's an integer. This can seem very silly, but it is not. It's actually pretty important. If we do a comparison, like here, this is the comparison operator. We are saying, is 4 string equal to 4 integer? And the answer is no. Why? Because one is a 4 inside a string. We are using the string there, while the other one is a 4 that is an actual number. They might seem the same, but Python does not treat them the same. Obviously, you as a human have the advantage that you know how to interpret it. For you, it's the same, but computers usually are not as smart as us. Therefore, you need to just be very specific. Okay, this is an integer. This is also the same value. And that's what we're going to do here. We are going to have the numeric variables. In this example, we're going to have the float 4. So this is another variable that we declare, and we're going to assign it to float. Now, you can see how these two are not exactly the same. This is a 4.0 because it can have decimals, and that can have some complications in the future if you're not if you have some problems with precision. But this one is an integer. It can only be 4. It cannot be 4.3, 4.4. In some operations, that can be very tricky. Therefore, I recommend you to just make sure that you're doing the correct arithmetic and you're taking into account the data types. With that being said, we're going to compare the float 4 and the integer variable. You can see here how Python recognizes them as the same, even though they are different data types. That is because, as you learn in your algebra classes, even though it has some decimals, 4 is still 4. It is still a 4.0. Python has enough precision to know that they are exactly the same, even though it might not seem like it at first glance. Now, values can be converted from one data type to another one with some specific functions like the integer function. Let's run this separately first. If I run this first, Python is making this string into a number. There is a lot of limitations. Python is using some very internally very powerful assumptions on how to read the variable from one side to the other side. Therefore, you just need to be careful whenever you are using these functions because they might not be able to read your data. As an example, we can do int, and we're going to do the same 4, but instead of making this 4 like this inside the string, I'm going to put a space. It still reads it. So Python is smart enough to do that. We could be something like 4 and space 4. And it won't be able to cast this as 44. It won't be able to convert it to 44 because the 44 is not the only value here and there is some ambiguity. In this case, Python was still able to remove this space and read it as a 4. Therefore, just be aware that there are some limitations to these functions and you might need to do some pre-processing before it in case that you have bad data. And again, this is more of a concern when you are importing data from somewhere else, and Python reads it differently than you want to read it. The system that you're taking this data from might also make some assumptions on the data, depending on how the data looks like, and you just might need to read it in another way. With that being said, list and other more iterables also have data types. So we can make a list bar here. And then I will have the type of that data. And you can see there is a list. That does not help me that much. That tells me that the list variable is a list. Now, keep in mind, from our kind of looping example beforehand in another video that I will also pull over here in case you need to revisit it. A list and most iterables can have multiple variables inside them. So you can use that global variable to some degrees. It is not a global variable in the true sense, but it is a variable with other variables in a certain order. In the case of a list, that's why we are getting this list type, but we are not getting each of these individual types. Therefore, if we want to check if of these types, we are going to iterate to the list, as you can see here. We're going to just print every single type of every single variable in this list. As you can see, here we get class integer, integer, and integer. So it went through each of these values and then it printed the class of each of these values. It treated each of them as different values for the whole list. We can also do a tuple here. And we are going to see the type of the tuple. Yes, for demonstration, as you can see, it says tuple, so that is correct. And we're going to do exactly the same thing. We're going to go and iterate to the whole tuple and print each of the types of these variables. Int, as you can see here. Now we're going to do a little bit more with data frames. Data frames and pandas in general expands a lot on Python and their data types. I'm just going to show you some basic concepts, and you can see more in my video about slicing data frames and manipulating data frames with pandas and other objects that I will also put somewhere over here. Now, we are going to do one of those ways, that is creating an NP array, an NumPy array, that is going to have these values. So this is going to be our data. And you can actually use this variable explorer to see the data. So you can see here, I have integers here, but I also have a string. Integers, string, integers, string. And now I'm going to convert that into data frame. Notice how each of the columns has both numbers and text as part of the variables. None of them has only one of them. So we can print that. That is the same as I showed here. And then we can use the function dtype in the method dtypes for this. You can see that it returns as objects, an object as the dtype of the whole data frame, because it's an object at the end of the day. A data frame is nothing more than a very complex object that Python uses to read some stuff. Now, we are going to try to be more precise with our data, because we might need those numbers to be read as numbers for other comparison purposes, and the strings to be read as strings. So I'm going to reshape my data a little bit. And then I'm going to see how df2 looks like. As you can see here, now I have a fourth column called label that has strings that I was thinking to put before. So I have 3 numeric columns and 1 string column. And I'm going to go with dtypes. Now you can see here that still X, Y, and Z, they should be integers, but they are being treated as objects because we did not declare a data type, and Python just said, okay, I'm going to treat them as objects. That is an assumption that Python does. There is a lot of ways to convert a column. This is not a single variable, it's a whole column into a different data type. As type is the most general function on NumPy that I will use right now. You have different ways to do it with different methods, with different functions. There is also downcasting, upcasting, etc. However, for these demonstration purposes, I will just use as type. As you can see, I am making these 3 as integer numeric values and this one as a string. So I will do this. And what I'm doing here is just creating a copy of this specific column, making it an integer, and then replacing the original one with that one. The same process for the 3 of them. Now I'm going to call dtypes again. You can see here how these 3 are integers and the fourth one, label, is an object still. And that is good because to some degree, objects are also, strings can be treated as objects. So we will take care of that. Now let's try to convert this label into an integer. And you will see that we get an error. It says you cannot convert this into an integer of base 10 with the string flower. We're going to try to ignore the errors and force Python to do that. And you can see here that we didn't get anything. It just passed through the values and gave us the same stuff that we tried to get. So lesson here, be very careful with your data types because your data types can be very tricky. And sometimes when you import data from somewhere else, you might have assumptions being made into them. You might want to review those assumptions to make sure that you're doing the correct comparison that you need to do. Another important part of data types is that for comparison purposes, they matter. let's say that we do this. So this is df2x with values of 1 and 3, and we're going to see, give me where dfx is more than 2.1. You can see the first one is not, but the second one is true. And we will try to filter that through Python. In this case, it's the correct assumption. However, there are some other situations where you are actually going to need a specific data type and the most precise one, because if not, you might have it read incorrectly. Now, I will just point out that this is an introduction to data types. There is so much more that I will not be able to fit in this video, and this could become a 1-hour video about data types. If you are more into the mathematical realm, you can go ahead and try complex numbers. You can go ahead. There is a lot of more details and documentation that I will put in the description of this video that are just not as important, at least on my own opinion, for understanding data types for data manipulation. However, if you're interested in that, I might do a video in the future talking about the implications of casting to different data types, how you may have some problems with arithmetic, or some basic math operations if you have incorrect data types, etc. All of those other things and the difference between eye troubles, for example, and everything else, it's just outside of the scope of this video, and I wanted to keep it a little bit short for this remark. As always, if this was useful for you, please leave a like, leave a comment. I appreciate any kind of feedback that you may have, and I hope to see you later. Take care.